their lands. Let's say A was equal to A, B, C, D. What would be the determinant of A?
AD minus BC.
AD minus BC, the determinant of A, correct? So what they give you is they say that capital D here is equal to fxx, fxy, fyx, and fyy. Exactly. So what does that equal? That ends up equaling fxx, fyy minus fxy times fyx. But the thing is fxy and fyx are the same, so you end up with fxx, fyy minus f, and I like keeping things in alphabetical order, squared. Exactly. You need to find this capital D value. This capital D value is something you need to know. Now, did you spend some time looking at the proof? Because it's kind of heavy. It's kind of anybody look at it? Kind of heavy? Okay, I want to actually take a look at this because it's a good idea if you have a general idea. Back to that in a second, but here's what I want you to see. So you have this. What does this represent right here? What are H and K? The direction, right? The U vector and U is a unit vector, right? So the directional derivative in terms of U of F is this thing, right? Is this thing right here. Great, that's awesome. So if we take the derivative of that, we end up with this line right here. We then do some algebra, and we get this thing. The only thing I'm really concerned about is we end up here. Okay, that's wonderful. So where do we go from there? Well, they do something fun. All they do is they complete the square of this thing, and this represents the second derivative of what directional derivative? Any. U. U could be anything, right? Have we specified H? Have we specified K? We haven't restricted them at all. This could be in any directional. The directional derivative in any direction, right? So basically this accounts for any approach vector if you want to think about it that way. The point is you have one square here. So for example, this thing right here is always going to be greater than 0, correct? Yeah. K squared is always going to be greater than 0, right? So what they talk about in the three cases that they give you, they talk about this thing right here. Hey, look familiar right there? That's what we just, that right there is the determinant of fxx, fxy, fyx, fyy. So this thing right here is one piece. That's your D value right there. And hey, there's your f of x. So the cases are, so if, let's say D is greater than 0 and this is greater than 0, what do you know about the whole expression?
Greater than 0.
The whole thing is greater than 0. So basically what this says is the second derivative in any direction is going to be positive. And what do you know about a positive second derivative? What does that mean? Yeah, positive second derivative. Now there's like two things. Hold on, I'll help you with this. There's two things I remember from high school calculus, actually high school math. The law of cosines and positive second derivative, you smile. So what is that going to be? Concave up. Second derivative equals concave up. If it's concave up, that's well, the things that really shine through. Smiley face, concave up. So it's going to be a minimum, right? What happens if fx right here? What happens if fxx is negative? If D stays positive, this becomes negative and that becomes negative. The whole thing becomes negative. So if you have a negative second derivative, it means it's concave down. Exactly. So what happens if f(x) is positive, but D is less than 0? You can't conclusively have either one. You don't conclusively have either one, so we have a saddle point, meaning for some values, for some approach vectors, it's going to be concave up, and for other approach vectors, it's going to be concave down, hence the definition of a saddle point. We look at the saddle points that we've seen, the ones that you've practiced drawing maybe, those are the ones where you have like this and it intersects something like this, right? Those are kind of cool. We've looked at ones that are like nicely symmetric. Can you have kind of warped saddle points? Are they always this clean? No, they're not always this clean. The point is you have an icky completing the square here, which looks kind of terrible, but it's really not. And then you're looking at what do you have to do in order to make it positive, and what do you have to do in order to make it negative. If it's negative, frowny face, you will have a maximum. If it's positive, you'll have a
smiley face.
Smiley face. Exactly. When y equals 0, what does that mean? So you have f of x0, you end up with x squared, right? So it crosses here, and it's 0, 0. When x is 0, y is 0, right? And when x is 3, where is it? It's up here. So when you connect those 2 points, what do you connect them with? A parabola. It's going to go up. Yeah, it's hard. It's okay. Go right ahead. Okay, so we have those right there. So we have two more we want to look at. What are the other ones we want to look at?
Z equals 9.
You want to do z equals 9? Let's not do z equals 9 because it's the only one. You can't really see them. I wish I could rotate this. Like I could touch the board, touch this cube and rotate it. We'd want to look at this back plane right there. Right there. And what is that? That's when what? When y equals 2. Let's pick a different one here. Let's do y.
Why are we picking these planes instead of anything?
Instead of what?
I don't know. Anything else?
We want to know, these are the edges right here. Our domain is the base of this box, right?
Oh.
Our domain is the base of this box. So what we're trying to do is, here's the base, here's our domain right here. We're looking at what's happening on the edges. What happens on the edges? We found the critical point, which tells us about everything we need to know about the middle of it, in between. So if we do y equals, what was it? Y equals what?
2.
Y equals 2. If this is the case and you have y equals 2, what do you end up with? F of x comma 2, what do you end up with?
4 minus
X squared, sorry, equals x squared minus what? Yep, plus 4. Right. So you can't really see it, but on this back wall right here, on that back wall, how is it going to intersect? It's going to intersect with x squared minus 4x plus 4. When x is 3, what does this become? What is f of 3, 2? When you plug 3 into there, what do you get? 9 minus
8.
plus 4? Oh, sorry, 12. I can almost do basic math. Almost. It equals 1, right? So it, yeah, it is a perfect, yes, thank you. That would actually be helpful. X minus 2 squared. Thank you. So when you plug in x equals 3, it comes out to be 1. So we know it crosses here. Well, what about if it hits this one here right here? What we go, da, 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 da. So I'm looking at that back wall right there. That's when when x is equal to what? If I want to know where it crosses this, that's when x is equal to this line right here. Well, y equals 2 and x equals what?
0.
Yes. So what is f of 0, 2? What's that going to be? Plug 0 in for x right there. What do you get? 4, right? It's 4. So where's that going to be? It's going to be right about here. And what kind of shape is that thing? It's a parabola, right? So this back wall right here, what does it look like? It's a curve like this. Why do we know it faces up?
It's positive.
It's positive. And actually, where's the axis of symmetry? It's at x equals what? 2. That's where the vertex is, right? So it better bottom out where x is equal to 2. So we know it's there. And then what's the last one we need to figure out? What's that last boundary?
The back.
The back, and that's when what? It's when what?
X equals
We want to look at this back wall right
X
here.
equals
That's when x or y equals 0. Which one?
X.
It's when x equals 0. It's when x equals 0. Because look, we want to change y. We want to go across. So if we make x equals 0, what does this come out to be? F of 0y. What does to make the original this come out to be right here? 2y. 2y.
Linear.
It's linear, right? When y is 0, where is it going to be?
0.
It's going to be at 0. And when y is equal to 2, where is it going to be? 4. It actually hits right there. Great. So we know it's going to go on the back wall, like right about here, correct? So the point is, if you had a piece of plastic that you could bend, you know that its edge on this front plate would be a line right here. Its edge over here would be this parabola right here. It'd be a line right there, and it would be a parabola right there. And why are you doing that? You're trying to figure out where the extreme values are going to be. Where are the extreme values going to be? They're going to be, well, we know actually. What is it going to be? What's the highest value going to be?
9.
9. What's the only other point we need to check?
If there's any critical points
And we
inside.
did. What was the critical point? It was 1, 1. Do you remember? I think it was 1, 1. Was it 1, 1?
Yeah.
Yeah, you take you get 2x minus 2y. Yeah, it's 1, 1. So what do you have to do with that 1, 1 value? Plug it into
The equation.
the original equation, right? And our original equation, so it's going to be f of 1, 1 is going to be 1 squared minus
1, 1, 1.
2 times 1 plus what?
2, 1.
2 times 1, what's that going to be?
1.
1. So is that a max?
No.
No. So the max is going to be f of, where's the max going to occur? What's going to be at 9, but what do you have to plug in? When x is, so f of 3, 0 is going to be 9 is the max. And how do you find the min of this thing? 0, 0, exactly. F of 0, 0 is going to be our min, which is actually going to be what? 0 is our min. We know that because looking at our parabola right here, can it ever get low? Looking at the edges here, can the edges ever get lower than 1? Well, actually, can they get lower than 0?
No.
We know for a fact that this one doesn't, right? And this one doesn't, and this line doesn't. I guess we don't have to check right here, but what this parabola right there is, what was it? It was x squared what?
X minus 2 squared.
Yeah, we know the vertex occurs when x equals 2. Oh, actually, does it go lower? Let's see here.
Where?
2 squared minus 8 is -4. -4 plus 4 is
0.
0. So where does the minimum also occur?
Right there.
Right there. So what is that point going to be is the real question. We know also where
That would be, like, yeah,
2, 0? No, remember it's over on this plane right here. So x is going to be 2, and what's y? What's y going to be? Is it 1?
2.
Isn't it 2, 2?
Yes.
Like this point right here I think is
2,
2, 2, right? Plug in 2, 2 into the original equation. Let's hopefully this comes out nicely. 4 squared minus 8
8.
plus 4 is 0, so it does work. So you have to be really careful on this. So do things get a little bit more complicated? Absolutely. So here's what this looks like. That right there, that was supposed to be a line, right?
Yep.
The height is 1, and that goes all the way up to 9, right? Over here, this was a quadratic, right? And it went from 0, 0 all the way up to 9. And then on the back here, that was supposed to be a line, right? And it went from 0 all the way up to 4, I think. And then over here, this was supposed to be a parabola, right? And we figured out that the vertex was when x was equal to 2 and y was equal to 2. And what was the output value? What was the z value right there? 0. Exactly. So we ended up with this thing right here. Exactly.
Wait, so how many are there?
6.
I think there's.
You should do it, like,
Hell yeah.
Can you prove that in equation?
I think there's 6. We'll try to do it with an equation. Yeah, hold on a sec. Hold on. But it looks like to me, let's clip this in. That's about the best angle I can get that sees as many as possible. So we have this, and what did we identify here? We identify them as, let's go with, there's one right here. Looks like there's one there, 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 and looks like there's 6 of them.
Yeah,
So the real question is,
4 of them are
how do you
separate.
find them?
No,
Okay.
all of them are separate.
Okay.
And
Okay.
set them equal to 0.
They're all separate.
I'm not asking you for that. Just hold on. So we have 3x minus x cubed minus 2y squared
Oh, now I guess.
plus y to the 4th. So what do we have to find?
The partial.
Yeah, partials. I love that vehemence. Very good. So what do I end up with for x? 3 minus 2x.
Wait,
Oh.
wait, it's x cubed, not
X cubed. Thank you.
Yeah.
Shh, kids, one at a time. That'd be great. 3x squared like this. Is that correct?
And you said that equals 0.
And hold on, fy, what is that equal to?
Negative 4y.
Negative 4y, parentheses 1 minus y.
Shh. How about this? Let Shuhan talk, yeah?
plus 4y cubed.
Plus 4y cubed. Correct. Okay. So if we want this equal to 0, if we wanted this equal to 0, that's when x is equal to what? Plus or minus 1, right? And this one right here is where you guys probably fell on your face. I don't know, possibly. Negative 4y times what? 1 minus what?
Y squared.
No, y squared minus 1.
Is that correct? Like
Oh, I
this?
know
Is
you pulled the negative.
that correct? So this is when y is equal to
Negative 1, 1.
0, 1, or
Negative 1.
negative 1, right? So how many points do you see?
6.
I see 6 of them. Because x, so it's either 1, 0, 1, 1, or 1, negative 1.
Or negative 1, 1.
Negative 1, 0.
Negative 1, 0.
Okay, ready? Not helping, Chen. Not helping. There it is. I see 6 of them.
So 0 is like
for x, if it's x equals 0 or plus minus 1,
There'd be 9.
there will be 9.
No, there'd be 9 of them, yeah, because you have to pair up each one as long as you don't somehow overlap. I don't think you could if they're different values, different. No, you wouldn't overlap. So there's 6 of them.
Okay.
That's pretty cool. It's pretty neat.
That, or
Look, take a look at this.
paraboloid?
Right here, you see this?
Yeah.
Concave up, right? But then if I look at it right this way, it's concave down if you look at it like this, you see?
Oh, yeah.
So concave up and concave down means it's a saddle point. But right here at the top here, this point right here, it looks like every way you approach this top point right here, it's going to be concave down. It's going to be concave down, so it's going to be a max. Now, you need to remember, though, that determinant cross, you have to do that second derivative test because you can't just go left and right. You have to go in every direction. And the only way we have to do that is to look at like fxx and fxx times fyy minus fxy squared. You look at those values. If they're both positive, it's a minimum.
Bell's about to ring.
Thank you. Okay.
Right about to ring.
Okay.